Welcome, everyone, to Mark Rober's TA's monthly office hours. Don't know if it's a mouthful. I don't know if I said it all right. But I am joined here tonight with my co-TAs, Grant and Chris. Good evening, gentlemen. How are you?
Hello, good evening. I'm doing very good.
Hello, doing well.
Good. Well, welcome to, is this our last one?
No, I think it might be. This might be it.
Wow.
I gotta
That's
check
crazy.
Yeah,
Time flies.
I didn't think about that, but yeah, I think we're done.
Wow. How's the course going for you guys?
Not bad. We'll spend the day going through some stuff tomorrow, but it looks like there's some pretty cool projects coming along. So, yeah. How about you guys?
Yeah,
Well-
it's been going good. It's been going good. It's been nice. There's been a lot of really specific questions, which is fun because either I'll know the answer to those questions, or there's a very specific thing for me and the other student to research together to figure out an answer for. So I've been enjoying just this section of the class. There's been a few challenges here and there, but so far everything's been going pretty smooth.
Very cool. Yeah, it's been really kind of quiet over on my end. There's not a whole lot of posting going from the student. I mean, there are things, but it's just updates. There's no questions or anything. So, I mean, not a whole lot for me to do, which I guess is good and bad.
Hey, yeah, no, that's true. That's true.
So, hey, last time we were together, we were talking about corgis and ball launching things and whatnot. And I found the coolest thing that I shared with Chris, a ball lifter mechanism. Did you see that in Slack, Grant?
I did see that. Yeah, I didn't actually click on it, but I saw that it was sent.
It's worth clicking on. That's all.
Yeah, that's pretty cool.
So, and it looks like we've got Paul joining us here. Let's say hi to Paul. Hello, Paul.
Hello.
Hey, y'all. How's it going?
Good. How are you?
Doing well. Yeah.
What brings you by this wonderful evening?
Well, yeah, my son and I are doing this class together, and I've missed all the other office hours. And we actually did have an area where we were seeking advice on the latest build, and thought I'd join and see if this was a good group to ask.
Well, we always like to think so. And I don't know if the other TAs noticed what I did there, but I just kind of let things play out to discover if you were maybe a TA we hadn't met yet or a participant.
Yeah.
I've stuck my foot in it before, Paul. Oh.
I just let you roll with it now. We'll see what happens.
Yeah.
Exactly. Yeah, do you mind if I ask my question?
No,
of
please.
course.
Yeah, cool. That's why we're here.
I'll tell you what our build is. We're in. My son has a habit of not practicing his drums every day when he should, and he's supposed to put in, like say 15 minutes a day. And then what always happens is on Tuesday when his lesson is, we're like, oh no, he hasn't practiced a lot, and then we're like cramming and trying to make it happen. So it's something to keep him and us accountable, right? And so the build is a machine that will determine whether he's practiced that day. And if he has not, we're going to build a sign on the wall, kind of like one of those workplace accident sites. Like, it's been this many days since an accident, but it'll be like, it's been this many days since I practiced the drums, and it'll like increment up each day. And then it's got a doomsday device built into it. So it will actually email his drum instructor if he misses, say, 4 days in a row. And so we came up with the design, and we've gotten the circuit working. And so we've got our little, proximity sensor that we're using to determine if he's spending a certain amount of time in front of his drum set. I have the email wired up so we can fire off emails using, what is it, IFTT or whatever that is.
This and that, yeah.
That one.
That's right.
The part where I could use some advice to help my son work through it is with the Arduino, like kind of the time and day based part of this, right? So like, if essentially we want to like count up how many minutes he's practiced in a given day, and then say like at night, that's when we'll do the processing and say like, okay, was it a pass or a fail today? Increment the light, reset it back to 0 if he did practice, or increment it up by 1, and then if we got to 5. And so it's that because Arduino doesn't have its own clock built into it, I've seen various ways to maybe approach this, like to determine has the day changed, or like what you know what I mean. Just that part of it. I didn't know if you had a good. If I want to do that like the same time each day and then check like is the next day yet? Should I just be like pinging the network time clock, or should I use like a cron function? Or I saw like a cron library and stuff, but it's kind of out of my element. So I'm curious what y'all have done.
Okay, so you've done a lot already, but you say cron, which makes me believe you know what Linux is.
I do.
Okay. And you figured out if this, then that.
Mm-hmm.
But how are you communicating between the Arduino and the internet with if this, then that? How is that?
Oh, we've got the Wi-Fi Arduino for this build. So, so we're just connecting through our home Wi-Fi.
I'm sorry. Let me pause that for a minute.
Yeah.
So it seems to me that, and I'll let the other TAs jump on this. I might have to go take that. But it seems to me like if you've got the Wi-Fi and you're connecting through that, then there has to be a timer function, a day and then a time of day that you can implement similar to a cron tab, right? Because the way the cron works is it just goes through and it says, okay, am I on this day of this month, this day, this hour, this minute, this second? And you say, okay, this is true, but then you have to have that daemon running the whole time. Let me go take this and let the other TAs jump in, and then I will be right back with you.
Sure. And I'll just add for the other guys, we did implement a network time clock or like connection to one, but only in as much to like for the, what do we call it, a proof of concept or whatever, just to like, I can ping it, I can get a time back, I can say what day it is, and but then I don't know, should I just be pinging it every minute and saying like, hey, has the day changed yet? Or is there like a smarter way to do it? It's kind of, I guess, the question.
Grant, gonna go, or you got somebody want me to?
You got anything, Chris? This is admittedly like just a little out of my element in terms of what my expertise is.
I built a similar product a while ago that was not obviously the same as what you're working on, but there's a shield out there, which is a data logging shield that also has a real-time clock on it. So that might be an option where you can interact with that clock by various inputs. So in my application, I had a temperature sensor that was keeping just a log for temps and temperature inside of a machine, which is a failure point. So it's possible that you would be able to do something with your ultrasonic sensor when that trips to actually write something to that data log, and that write would have a timestamp on it. And that might be a possibility for you, and they're pretty inexpensive. And the nice thing about a shield is, since it goes right on top, you still have a breadboard you can solder things onto. If you need to have lights or whatever, you can still do all of your inputs. It keeps all of your mounting points. Everything is there, but it basically just adds, an SD-based data logger with a time clock.
So here's a question I had on that. So just to give you a sense of my comfort with this stuff, is like, I can tend to make this stuff work, but it's like, I don't really know I don't know why it works. You know what I mean? Like, so I'll like.
Same here. Don't worry about that. Page, you're fine.
Like everything is brute force, and it's like the code isn't elegant. It's just like I'm just making it happen.
Yeah.
But so that's the context for this question, which is, with the last build we did, we made a little like a lamp that like spins around, and each side has a different picture on it. And
I
is a
saw that,
different
yeah.
color. Yeah, and so like, and we wired up some buttons, and each button is a different color. And so
Yeah.
you push the red button, it turns to the red side. And so for that, we stored the last button press onto, is it called EEPROM? Or,
Mm-hmm.
yeah. So when you're talking about adding a shield for storage, when would you do that instead of just using the onboard EEPROM?
The one thing that's nice about with the extra storage is, I mean, it's not, you can write data independently then from the main EEPROM that's driving, that you're loading your software into. So it's actually just a secondary data channel.
Mm-hmm.
So it can run independently of your program, and it's, if you need to take the memory out or the card out, whatever, it's just a different way to approach it. And the only reason I was thinking of the data logger is because you can kind of get, you know, that combo deal where you have the clock and the logger all in one. So you're saying, and the only reason I kind of went there is, you know, what you're trying to do is time dependent, right? And so if you have something that is an action that is triggering at a specific time, you already have all those components together. And I guess I was kind of going down the same road you were saying, it's kind of brute forcing the code. This is, in my opinion, kind of a way to brute force this project.
Yeah, sure.
And I'm sure there's a million different ways to approach it.
Right.
So, yeah.
So I have my job is I'm a product manager at a software company. And I actually booked a meeting with one of my developers today, just to like, he was like, I was like, dude, I got to ask you about this Arduino. And actually his answer was, use a Raspberry Pi, because then you can just say, do this thing at midnight, because it has an onboard clock. And I was like, oh, yeah.
Oh,
That's where you got the cron idea from.
Yep. And
yes, he is the one who also said the cron idea. Yeah.
So the other thing I was thinking too, if you use the millis function, right?
mm-hmm.
So you set up the longest variable that you can come up with on an Arduino, which is, I believe, is it an unsigned integer? Or is it a double? I forget.
I think it's an integer.
Yeah, but anyways, let's say you initialize an unsigned integer, and then you just basically say, if it's been more than, say, 10,000 milliseconds, or figure out whatever interval you want. If it's been more than 10,000 milliseconds, then do this thing, trigger this if the IFTT code.
Yeah.
It's not exactly a cron, because cron is a daemon that works differently, but it would work. So what would we need? 3,600 for times 24, something like that. Yeah. To set up your timer that way. So
because maybe this is not the right way to do it, but the way that we were using the proximity sensor was to ping like every second, and then every second that he's in the right proximity, then we say, oh, that's 1 second that he's been practicing, right? And so so assuming that's not a horrible way to do it, then I'm already counting seconds, and so I could just increment numbers to count how many minutes it's been throughout the day as well, and then kind of do what you're saying, like piggyback on that loop to do what you're saying. But maybe that what I'm doing with the pinging every second doesn't make that much sense either. I don't know.
I think it's as valid as anything else. I mean, I think that works.
You're not using the microcontroller for anything else where you need the processing power. Make it work.
I'll offer a not necessarily a workaround, but this is probably what I would do if I was faced with this problem and had to come up with a solution very quickly, and didn't want to cause myself a lot of grief. Just so I understand the problem correctly, what you want to be able to do is check every day at a specific time whether or not practice has been practiced, but also sort of like how long you want to have a 24-hour check just to double check what practice, if any, had been done. Correct?
Yeah, I need to process the days practicing and see if he met the criteria once a day.
So if you're looking for just a way to have some trigger or indicator to initiate that check, this is isolating the system, and definitely not the most like professional way. But I think it might be somewhat elegant. Is I would go and I would buy one of those wall outlet timers at like the hardware store and plug in a bulb and have it turn on once every 24 hours by setting that dial, and have that connected to a photoresistor on the Arduino, that when the photoresistor is triggered, that's when it does the check. Now that's really goofy. That's not super practical for like an end game product, but that's how I would solve this problem right now if I had less than 24 hours and I had to come up with a solution that worked.
Actually, the cool thing about that is it gives a way to test.
Yeah.
Like if I do it my way, I have to wait a night to know if I got my code right.
That's true. Yeah.
And your way, I can just turn on the light bulb and I'm like, that's my trigger. So maybe even just as like a test harness, that might be a good alternative way to do it.
And maybe there's a better way to do it, still in the same vein of having some external thing that already does a really good job at keeping track of days and times or whatever, to just simply send a signal to the Arduino to trigger it to initialize the end of day gathering or whatever. But that's sort of my 2 cents of what I can offer as a potential one of many solutions.
Well, do we need to know when? Do we need a light? I mean, is there going to be enough light in the room to do that same thing without?
Yeah, that's true. I mean, maybe there's a different thing that you could connect to that socket that would, emulate some sort of just like pulse or on off. That was just the first idea that I had. But if there is a light in the room, that could, that could cause it to go wrong, unless it's in, contained in a little box and the light is inside of the box with the Arduino and they're tucked away.
It could be literally as simple as a switch too. That it's on a practice. He's got to hit the dead man switch just to say I'm here.
Yeah. Put the drumsticks in a piece of PVC with a reed switch in it.
That's a great idea. You take the sticks out, and that's your trigger.
That was one of our potential solutions for like as he practicing is like, did he take the thing out?
Yeah. That's a great idea.
But then he's got to put them back.
Yeah, 9-year-olds don't always put stuff back. But,
I will say this.
They do, but it's just never what you expect.
You are probably the first person I've ever met who wants their kids to play drums more. I mean,
yeah, that's a good point. Actually, so maybe this will trigger another idea. They are electric drums.
Dude, what are we doing? Messing around with lights and timers and things. Can't we just tap the audio output on that?
Oh, that's a good point. Yeah.
That could work. I wouldn't know how that would work, but that seems like that realistically is a thing that's possible.
If you got a signal out, that signal out would be your switch.
Yeah, when he turns that thing on every night.
Yeah. Well, but you've already figured out a way to determine whether or not he's playing drums and how long he's playing for. You're right now concerned with how to check every day whether or not that has happened.
This is true.
That's true, but although to your point, Grant, that's why I liked the proximity of sensors, because it's an easy way to tell the duration too. So like with the sound thing, be like hits the snare drum, it's like, okay, we're practicing now. But then, then what? Like,
I think silence for 30 seconds or whatever. Or, you have to.
And I think that's where I was going with the data logger in combination with that proximity sensor. So as long as there's something in that field, it'll count continuously. It's just, again, it's a clock. So I mean, as long as it's seeing a signal, it's going to kick back a numeric value inside that time frame. that there is something occupying that space.
There is a more interesting project to be done here, because now that you guys got me here, it has a MIDI out, right?
Yeah.
So that MIDI writes things that include duration, right? And so like if you had, even though there would be spaces in them, I don't know if you guys know what like MIDI tends to look like when it gets like input on a DAW, like recording interface or something. It's like looks like a Gantt chart or something, right? With like long bars. And if you sort of like look at those in aggregate, you could kind of say, oh, you practiced for this long, even if there are breaks in it.
Yeah.
That would be a kind of interesting way to
So
to figure that out.
you're thinking of taking the attack signal, because MIDI, as I recall, is attack,
Yeah,
sustain, release, decay.
exactly.
But really, all we need to know is, okay, so if you're playing drums, it's relatively fast place. If he's doing, hit, wait 30 seconds, hit, wait 30 seconds, we wouldn't really expect that to be practice, or at least I wouldn't. So you could have a separate timer, once he hits something, put a heartbeat monitor on it. If we don't hear anything within the next 30 seconds, it's safe to assume he's stopped.
Yeah.
Right.
Mhm.
So a different type of timer.
What would that look like? I don't know. I've not used a heartbeat monitor.
Well, it's just basically looking to see if a circuit's active, to see if something's alive. They come in lots of different ways. A heartbeat monitor is really something more with networking. Electrical engineers use something different, but the name escapes me right now. It doesn't matter. It's the same basic idea. Is something giving off a pulse?
So that you would just put a delay in and loop it, and that becomes your heartbeat. So it could be an audio sensor or something that checks every 10 seconds.
Yeah.
And
then really, I wonder if we can even get fancier than this. Do we need to pull the Arduino every day, or do we just need the Arduino to tell us when it's doing something and let software pick up the rest on the IFTT? I haven't done IFTT in a while, but can we say something if something hasn't happened in 24 hours, then?
That's interesting. Yeah, I'm only using it to send email right now, but I haven't looked at using it for more of the project.
No, because I mean, if we can, did he pull the sticks out of the holder?
Mm-hmm.
Okay, that's great. He did. That's one way we could trigger it. Or if there's a click, we could start a timer then and stop the timer if we don't hear another click within 30 seconds of the last click. So every time there's a click, an output, we restart the timer, right? We restart the 30-second or 10-second countdown. And at the point where that goes off, we realize, hey, we're not hearing clicks anymore. He's slacking,
Yeah. Hey, can I ask a tangential question? Because when we were talking about the bootstrap and testing thing, it got me thinking about something. When we've been doing this stuff, the only way that we know how to test is just to write stuff to the serial monitor. But can you step through code or anything like that? Real time, the way like I would in .NET and put a breakpoint, and then I can step through it one thing at a time and view the variables and stuff like that with an Arduino, or is it?
Yeah.
You can. Yeah.
Oh,
well, how do I do that?
Okay. Well, it's not easy, but you can. Let me ask you, do you have any tools available to you that like a serial to UART? I just kind of need to get an idea of what your skill set is.
What kind of tool? I mean, I've got lots of home improvement type tools. I do have a soldering iron.
That actually answers my questions.
Okay.
But you've never heard of anything like GDB or? Okay. So to answer your question, yes, it's possible. But the way that I would actually recommend that you start it, and I don't even know where I did my keyboard. Sorry, the reason I've been running around and I'm a little distracted. We had a mailbox break in.
Uh-oh.
It's been happening a lot in the area lately. So I was just reporting it, and then the sheriffs were out there and they're saying, yeah, we're here, but we can't see where there's any damage.
Huh.
And I'm like, oh, that's interesting. So that's when I ran out to show them. I'm like, you see that door? Yeah, that used to be attached to the mailbox. Oh! So now my neighbors are getting home and they see the sheriff's out front and they're like, hey, is everything okay? So I'm distracted. Okay, so there's this website that my friend runs. It's called walkwe.com. And it, among other things, is an Arduino simulator. I'm going to put a link for you right here.
That sounds interesting.
Yeah, it's really cool. So Walkwe has, among other things, a way to, and the documentation he's still working on, but you can actually search for Walkwe and GDB in the docs, and you can walk through each. I'm going to share that with you too. But you can actually walk through each cycle of the Arduino, of the ATmega 328 as it goes through things.
Oh my God.
And
I mean,
so
you can imagine all the time that I've spent just like, let me try this and like spit it out. And I got to like, especially now that I'm using the internet, wait for it to connect, wait for my thing to initialize, go through the loop. And then like, all right, let me look at the serial monitor. Oh, I got the code wrong. Go back.
So that might be a way for you to at least get started. Now, the typical way that I would step through Arduino code, and I think I've got one here, is through the ISP interface, the in-system programmer, or SPI. Let me get to an overhead view. I would connect up to these pins back here. I mean, this is an FPGA, but I would connect to the programming header with a little doohickey, and then I would be able to step through it that way. I think I have a better... Let me get another camera view here. Which one is it? No, that's definitely not it. Okay. See these little pins back here?
Yeah.
Those are the ones I would typically tag but you need a different device that attaches and gives you a serial to UART. Let me find that for you. Or you know something? I'm probably working too hard and confusing you. Why don't we just find an Arduino resource why don't we just Google how to step through Arduino code, how to debug? But be honest with you, most of the time what I'll do is exactly what you do and do a bunch of debug statements.
Mm-hmm.
But yeah, let's just find you a guide on how to debug your Arduino. I wonder if my friend Sean Heimel has anything. Here is a guide. I haven't had a chance to look at it yet, but I will share that with you. But the device that you need to attach to it, the little serial to UART converter thing, it's cheap. It's you can get like 3 of them for $20 on Amazon.
Interesting.
Yeah.
And so you can't do it through the USB. Like, maybe it's not fast enough. I don't know.
Well, it might be possible. I will say I don't know enough about Arduino to be able to answer that for you, but I would tend to think no. So the Arduino is two things. It is the ATmega 328U microprocessor. That's the thing that you want to see the code on.
Mm-hmm.
And then it's the SAMD11 that does the UART to USB conversion,
Mm-hmm.
and that loads the bootloader on this guy. So really, all of your code is executed here. This guy just does housekeeping, and he sits between the Arduino and the USB. So it is conceivable that somebody has code out there that lets this step through this.
Mm-hmm.
I don't play with Arduino enough to know if that exists or not, but it is possible. But really, what I usually do whenever I need to step through something is I just go for the JTAG or the serial header, like here, because this connects straight to this.
Yeah.
That's usually where I go. Now, let me see if I can find the there should be a little USB to UART converter. Super debug cable on Amazon gets you a USB cord, so don't get that. Really, you want the GDB. Okay, so there's an FTDI cable. You're going to have to probably get a USB to UART converter. Oh man, the amount of trouble that I am going to cause in your life right now.
Man, if this works, this is going to be life-changing. I mean, like, it's just amazing how long it takes to debug by like running the code and seeing what gets spit out, you know?
Yeah. And
to be able to change stuff on the fly, like, man.
That is okay, so I found an option that's two of them for $8, but I think there's actually a okay, so this is not what I am not recommending this product, just to give you an idea of the type of thing that I'm looking for. Can you click on that, or does it just show up on the screen?
I can copy it and paste it. Yeah.
Okay, I am not recommending this product. This is not what I'm looking for. I'm looking for USB to UART, USB to TTL, I guess. These aren't what I've got some in a box, but I'm redoing my office. I don't know how long it'll take me to go find that box. I'm looking really for a cable that looks a lot closer to this. But this is not even the cable. Oh God, that's a horrible link. That link has a tumor. Let me get a... Oh, it's a refer link, that's why. Okay, I'm looking for something that looks a little closer to this. But I bet you if we do like the, or I'm sorry, let me give you a chance to copy that.
Oh yeah. Got it. Mm-hmm.
So I bet you if we go to a link like this one, that will get us a heck of a lot closer to the information we need and a product that is known to work. I know I'm kind of monopolizing the conversation. Did you guys want to say anything?
No, I'm enjoying listening.
So yeah, so when it's actually really useful, especially if you want to get into some more advanced programming, to know how loops happen and how the microcontroller itself keeps track of where it is in a loop and if it's going to go back and start repeating things. And all of that, getting to know what line of code execution you're on, it's all incredibly valuable. So if it's a skill that you've got the patience to learn, it's a useful skill to have.
Yeah. Yeah. For sure. Yeah, I'm going to look deeper into this debugging stuff and which cable and what's the right word, harness or whatever to use.
Yeah. So the two things you're looking at, voltage, what voltage does it use? Logic level does it use? Because the Arduino, I believe, is, even though it's a 5-volt power, I think it downplays everything to 3.3 volts, doesn't it? Or
I think it's all at 5 volts.
Oh, it's all at 5. Okay, so then you want
there's the smaller Arduinos. Some of them are 3.3 volts, but the Uno and the Mega are 5 volts.
So that's one of the critical things that you're looking for, Paul, is that you have the right voltage for your board. So your weather board, or your USB programmer doohickey, if it's a 3.3 volt, you want to hook up a 3.3 volt debugger. Otherwise, you're going to get gibberish, or it's not going to communicate properly. So that's the critical concern mostly. And then what if I look for Arduino and GDB? ESP8266. And then the other thing too, which Arduino are you using? Let's make sure it even has ICSP output.
For this one, I'm using the Arduino Uno Wi-Fi Rev 2. Does that sound right? Or maybe it's just called Arduino Wi-Fi Rev 2.
I don't know. I probably should spend more time.
It does have ICSP.
Okay, cool.
Yeah, it looks like just everything that an Uno has just has the extra Wi-Fi chip on there. But then let me double check. Yeah, the operating voltage for it is 5 volts.
Okay. Then the next question is, what is the preferred tool chain for hooking that thing up? And I don't play around enough with Arduino to know. Do you debug stuff at all, Grant or Chris?
Oh, no, not at all. I barely write stuff, but I'm getting there.
Okay.
What do you mean by tool chain to hook it up to? Not that I have the answer, but I'm just curious. I don't know what that question means.
Oh, okay. It's electrical engineering jargon. So tool chain is what software and hardware you need to communicate with a particular microcontroller.
Gotcha.
So, like, if I was doing something like the Texas Instruments MSP 430 FR20, I don't know, 2633, just off the top of my head.
Okay, yeah, sure.
I would need a different IDE. So, like, Arduino has its own IDE, integrated development environment, called the Arduino IDE. Mm-hmm. But Texas Instrument uses Eclipse. I would need a different programmer. Like Arduino has that little built-in SAMD11 that does the code push onto the ATmega.
Yeah.
Whereas the TI needs something called a JTAG debugger programmer. So toolchain is kind of what's all the software and hardware tools I need to get from code onto microcontroller.
Gotcha. Okay.
So, And I
Yeah.
feel like Arduino, and it could be that I just don't know many features of it, which is possible,
Mhm.
but I kind of feel like the Arduino IDE is meant to be a simplified interface that may or may not have that level of debugging.
Right, for sure.
The way I debug typically is just from the error logs. That's the only way I've actually found.
Oh yeah,
running.
I've done that.
Yeah, and I mean but I've never seen anything more elegant than that.
Mm-hmm.
Yeah, usually it's error logs and then Googling the messages I get when compiling. But if you're talking about like the program compiles fine, but it's not functioning properly, I've just usually trial and error. But typically the things that I'm testing don't have a particularly long boot up time like it sounds like yours do, so it hasn't been incredibly frustrating to just like reset and try again and then, oh, that didn't work, what if I adjust it here, reset, try again. That's usually what I do, which works for my workflow. But I would probably equally get frustrated if I had to wait a couple minutes in between every reset.
Gosh, yeah. Okay, here's something that I have not read yet, but I'm going to share with the class. So Arduino Pro IDE. Anybody ever heard of that?
Ooh, that sounds fun. I have not heard of that.
So let's learn together.
Oh yeah, it looks like that's what it's for. The number one value proposition they list on there is execute your Arduino sketch step by step.
Step by step while it's running on your Arduino board.
That's it.
Look at that.
Pause your sketch. Yes, that's exactly what I want. Inspect variables. Exactly what I want. Latest alpha preview version for Arduino Pro IDE. More details to follow soon. No, give it to me.
It's an alpha preview.
It looks like the most recent update was February 26, 2020.
And it doesn't require a separate like wiring interface other than the USB?
Well, see if it can re-task that SAMD11 so that it's not only acting as the bootloader, because really all that other device is doing is just becoming a USB to UART interface. So there's really, again, no reason that the SAMD11 can't do that if somebody's programmed that debugger to, after it uploads the code, to convert back to become the debugger. And then once you're ready to upload code again, reflash the SAMD11 so it can be the bootloader again. So theoretically it's possible. I've just never seen it happen. So that's
on the Arduino site under their software downloads, we've got the current IDE, which is 1.816. If you scroll down further under experimental, there's 2.0 beta. 2.0 beta does contain live debugging, and that's available for download right now.
I wonder if that's the version I'm already on.
Good find, Chris. Well, if it's
that was a good find.
If it's beta, I doubt they've released that to people unless they go looking for it.
Okay.
Right.
Well, it's on. I mean, if you go to Arduino software under downloads, you got their main. If you scroll down a little bit more, under experimental, so it is on their main download page.
Yeah, it looks like the supported branch is 1.8.16, and Chris is pointing us to 2.
So yeah, just scroll down a little further.
Yeah, I see it. I absolutely see it. So probably, Paul, unless you went looking for it.
Got it. Yeah.
I mean, but that would make me like or I hate to say, because it sounds condescending, and that's not what I mean to convey. But that would encourage me to find more uses for Arduino in my projects.
Yeah.
Yeah.
I'm gonna download that right now and play with it.
Yeah,
I am too.
Yeah, it's interesting you say that, like the way you talk about Arduino, like when I say like, oh, I don't know how this stuff works, but I can make it happen. I can make stuff work.
That's good.
Part of the downside of that is like I don't know which parts of the Arduino I'm using. So when if I want to work on a build and say like downsize, if I want to make a Christmas ornament and I don't want to bolt an Arduino to the back of it, like I don't know, like, well, which parts of it am I using, and like, what could I replace it with, like which chips and so forth. You know what I mean? And so I have to get to that next level of knowledge so that I can start to like source individual components and so forth instead of having this bulky thing.
That isn't so easy. It is a little more complicated.
Yeah.
But the ATmega 328U is the chip that is the Arduino. When people say, well, what is an Arduino? It's really that IC.
Mhm.
And there's lots of other different variations of that. Not just the ATmega, but I will go get something and I will share it with you while the other people fill the dead space. But yeah, there's other ATmega devices out there with fewer pins, like ATtiny. There's the, like the Arduino. Oh God, is it the League? What's the big one? Grant and Chris.
The Mega.
The Mega, which is based on a different ATmega chip.
Oh yeah, it's like 2650 something. Yeah.
Yeah. So there's lots of different ones out there, but I wouldn't say that necessarily is the first thing you need to do. Go have fun, man. Make a drum thing. Go have a good time. And yeah, if you do want to make a Christmas star or whatever, there are other things out there. Here's what you do. Do you know about the Arduino board manager?
No.
Okay. So when you open up the IDE, there's different libraries. That
I do. The board manager.
Okay.
Yeah.
Yep.
So yeah, board manager, it'll tell you, there's the Arduino Yun and Uno and all these other things, and see what other boards that you can install that work with that IDE.
Mm-hmm.
And go click on one, like SparkFun and Adafruit have a lot of cool things.
Oh yeah.
Go get a couple of those before you go out, trying to figure out, here, something I can save us all some time of me digging through boxes, and I will just share you what I was going to show you. And now I don't have to go look for them. But yeah, like the ATtiny 85,
Oh, yeah.
it's just a couple pins. And you can program it, and it can do a couple things. It can't do a lot of things, but most of the time you don't need it to.
Yeah.
Wow, look at that little thing.
Yeah. So spend some time at SparkFun, at Adafruit. See what they've got going on. The Discord channel for Adafruit is very active. I imagine SparkFun is as well. I haven't been on it recently. But if you have a problem in mind, here is something I have floating around. I bought a couple and I have yet to use them. But they've got the ATtiny along with the a carrier board. It has the pins broken out for you, so you can plug it in. And I got it working this was a couple years back. I got it working to load some code, and then I'm like, hey, this will come in handy. I've never used it. For me, it was a solution looking for a problem, and I've yet to find the problem it solves. Just because I end up, doing other things. So.
Wow.
Wow, this is like 10 different rabbit holes that I get to go down now.
Yeah.
All these links.
So.
Yeah, good.
I was going to say, solve your problem now, right? Get your drum machine working, then learn how to debug. Now we've all got something else to try, right? I've just wasted a ton of Chris's time and Grants.
I'm not
Hours
going
of their life they're not getting back.
It's not wasted.
No, it's not.
Yeah, we learned something new.
Yeah. That's one of the things I like about TA time. I learn new stuff all the time too.
I don't want to keep you all if you have other things, but I do have a couple other different questions.
Sure.
Yeah, there's nobody else in the waiting room, so go for it.
Sweet. Sorry. Okay, so one of them was when the last build we did, we used a step motor.
Mm-hmm.
Okay.
And I was getting this like awful whine sound, like a high pitched whine. Like, what does that tend to be? Like, is it a power problem? Yeah.
I have an answer.
Yeah.
And the only reason I know this is because I went through a similar problem with my 3D printer that was using stepper motors as well. Were you using the just included little, I forget the like CHP 300 or whatever, the like stepper motor that's included in the kits?
No, I bought a bigger one.
Okay, got you. You bought a bigger one. What stepper motor driver board were you using? Because that is probably the source of the problem.
I see.
It's
Tell you
motor.
it was really cheap, and a bunch of them came in the bag, so it probably was
Yeah. So it's definitely the stepper motor driver that is responsible for sending the very specific voltages that tell the motor what to do.
Okay.
And cheaper ones get the job done, but there's a wider margin for error, and then there's all of that extra noise. If you buy just a more expensive, what's the company? TMC 2209s. I think that's the name of the yeah. So a TMC 2209 is a really nice stepper motor driver that will make it virtually silent if that's something you wanted to do.
So this, I don't know if I'm pasting this in the right place. Do you all see that?
Oh yeah, we can see that.
I can, I think, but I can load it.
That's the to answer your original question. That's the driver that I got.
Gotcha.
So maybe just try a nice one and see if it makes the problem go away.
So the Silent Step Stick 2 is the microcontroller I usually is usually the microcontroller I recommend.
Okay. I see.
But I don't know how that translates into a module, because you'd want to buy the module. You wouldn't want to buy the IC.
This is so strange.
Let me open this.
You can even get the ICs. Waterot. Yeah, they have. Looks like they have modules. So cool. Yeah. TMC 2100, 2130, 2208. 5160, 5161. Okay, so they have the modules. Those are the ones Grant was saying. Cool.
And then, and also sometimes that noise can come from incorrectly calling out the amount of steps that are on that motor. So if you have a mismatch from the driver to the motor itself, you will get some noise or some chatter back and forth as it's trying to hit a step that it might not exist, if that makes sense. So, when we're talking, bigger industrial size motors and stepper drivers, there's a specific curve that you dial in to tune those motors. In this sense, you're literally just calling out that this is the motor. I'm just looking at some of my old code where I was having some of that chatter in, and you're saying that, this is the stepper and these are the steps that match this motor.
Yeah.
So it kind of sets it basically pairs the two together. So if you have a mismatch, you'll also get noise.
Got it.
And then there's also, have you heard of micro steps? So a stepper motor, it's got a bunch of magnetic coils, and it's got a magnet, and it will energize and it will draw the magnets into the next step. So these things are kind of, they're offset ever so slightly. It's like a vernier. There'll be like, let's say 4 magnetic coils and then 5 magnets or whatever it is. And generally what you do is you just adjust the polarity so it sucks the magnets into the next locking position. And that gives you a full step of rotation, if that kind of makes sense. Now, the other thing that you can do, set, and I think it's called micro steps is the terminology, where you just start juggling back and forth between 2 nearby coils and kind of, get it to attract. It gives you more granularity. It gives you horrible torque. I mean, it's just going to lock in at the next step position. But that vibration back and forth, that high frequency flipping is going to give you some noise too. So is it micro steps, Chris? The word I'm looking for?
Yeah.
Yeah. Don't do them.
It almost sounds like the same thing, Chris, that you're describing, except just doing it on purpose, right?
Essentially, yeah. I mean, it's, as Mark said, just go with, the normal steps in there. But yeah, you can do these micro steps. But yeah, there's really no holding. And if your micro stepping is off, you're going to get this vibration, chatter, weird noise coming back.
And some of the noise that comes from the motor is from something called Magneto Constriction. So whenever you have current going through a coil, right, it can cause the wires to actually contract and come towards each other. If you've ever walked by any high current location, you can hear that with the traditional 60 hertz hum, right? Everything makes that noise. So it's always just, vibrating. Well, the same thing's happening with those things. So if you have current going through these and it's too much current, you're going to get noise. So a lot of these things like the silent step, I forget the part numbers, Grant had them a second ago. But what those things are doing is they're automatically tuning the current curves, just like Chris was talking about, right? They figure out, okay, well, it doesn't need this much current. What a bunch of crap. And it dials it down so that you don't get that magneto constriction and you don't get as much noise.
That's great advice. I appreciate that. All right, my very last question, and then there's only a few minutes left anyway. This is such a boring question, but what do y'all use for like small parts storage? So like just with what's in it was like, we like drop it the first day. It's like picking it out of the rug still, like all the stuff. And like, I don't know. I'm just curious what y'all are using. I'm sure people have cool solutions.
I think Mark has an exciting solution. I get Mark's gonna.
No, I've got storage tubs that I've labeled, like motors and pneumatic. Then I go down to like the small tackle box size stuff for a lot of it.
Mm-hmm.
Okay, I am so glad you asked. How small?
I mean, like little, like that, right? For like little, like breadboard buttons and capacitors and stuff.
So this is by IDE Tech, and I can give you some links here if you want.
Yeah.
But they've got a wide variety of these boxes, and they have them in lots of different sizes. And you can, depending on what size containers you want, they sell them also for bead storage, right? So this is one of their bigger compartments.
Yeah.
They're relatively inexpensive considering how much storage you actually get out of these things.
Yeah. No, that's perfect.
Yeah. And then what else is there? I think that's pretty much it. I think those are the 3 sizes. And then the micro, right? Each one of those is a storage thing.
Yeah, that's awesome. I'm like copying and pasting like all the links y'all pasted in here.
Yeah, let me get you that one, the ATEC stuff.
Man, guys, thanks for letting me monopolize you for an hour. This was awesome.
Oh no, it's all good.
This is like
Yeah, it's nice to have somebody to talk to.
You guys
Yeah.
may remember when you were starting out, like figuring out all this stuff y'all just told me would have taken like days and days of Googling and figuring out which thing was good and which blogs are nonsense. And
Yeah, no, that is one of the things that, you know, pisses me off when you get somebody asks a question like you asked and you get a dismissive answer. Like, well, you could have just Googled this.
right.
And you're like, dude, I did Google it. I found 100,000 results. You
Yeah,
know? Help me work out the signal to noise ratio here, you know?
yeah, exactly.
All right, so there is a non-refer link for that aid tech stuff. That'll get you close.
Sweet. That's
And
great.
aid tech has all sorts of different ones available to you. I mean, $20, $25 for me, that's a no-brainer.
Yeah.
You
Yeah,
know,
this would be great for the
Wow.
the regular shop too, like with all the little screws and nuts and stuff.
oh yeah.
I love this. Awesome. Well, man, I'm gonna let you guys roll. Thank you so much. This has been really super fruitful. I'm glad I logged on. And
Yeah.
Thanks for stopping by.
appreciate you letting me pick your big brains. And
Hey, just because I have a big head doesn't mean I've got a big brain,
I
sir.
don't know. I'm name calling. Sorry about that. Cool. Well, we'll see you guys at the next one or on the chats and stuff. But I really appreciate it.
Yeah, I think this might be our last one. I don't know if we're going to do another.
Okay.
We'll see.
Glad you made it.
Yeah.
We'll see.
Awesome. Well, thanks, guys. Have a good night. I'll catch you later.
You too. Thanks.
Yeah, you're welcome.
See ya.
Take care,
Bye-bye.
Paul. Bye. So in other news, I have a 3D print going right now. I think it's working. So I think
Good.
it was the plan.
What? That's incredible. How long has it been? I don't want to ask. I don't want to.
You're jinxing it. Don't
Send me
do
a
that.
picture when it's done.
Yeah.
Okay, so here's the sad thing. So this is really sad. I shouldn't even say this on recorded camera, but so I fixed it at like 12:30, right?
Yeah.
And I'm like, hey, these guys are going to want to know if it worked. Print. Walk back in, I don't know, 4 hours later. Like, nothing's printed. No filament loaded.
But it was going through all the motions, right?
It was going through all the motions.
It was practicing. It was
It
practicing.
was practicing.
It's,
So
it's a warm up.
it's been printing for at least 3 hours now with
Well,
no
that's a good
clicking.
sign.
It sounds good. By now, it would be clicking, making skipping noises and stuff.
Yeah.
So,
Wow.
Yeah.
Incredible.
so, well, that was a fun one. We got to
Yeah.
go through a lot of.
That was
rabbit
really
holes.
fun. Yeah.
Now I just
Well,
wait till,
gentlemen-
middle of next year to get my new printer.
Are you
Did
getting
you
the
actually
Voron?
put a deposit down on one of them?
Yeah.
Oh wow.
I would.
I don't have the space or need for one, but
No, it's
that would be
honestly
really cool.
it's got there's a lot of stuff I've wanted in a printer, and that
Mhm.
kind of ticked all the boxes. So
It really does. Yeah.
I'll sell my other Prusa, when this one ships, and
hmm
call it good.
So, what does this one do that the other one doesn't? Is this the XY?
Yeah, it's the
Yeah.
Core XY. It's big. It's a 4
Yeah.
foot square build plate. It has tool changers, so you can run up to 5 separate heads. So you can do multiple different types of filaments. You can do different colors. You can do water soluble filament for support. You can, the sky's the limit for that. The bed is a very, very different design.
Yeah.
And that's one thing that's really intriguing to me. So, especially when you get into a bigger bed, when they get hot, they'll warp a little bit just as the heat will deflect the build plate. This bed is comprised of many about 3-inch square individual panels that heat. So you don't have any of the warpage, and it'll also, each one's on its own thermistor, so it'll keep heating randomly just to keep the whole plate even. So it's not all on. It'll be on and off and kind of fluctuate to maintain heat. And it'll also only heat the part that's needed for the build size. So if you're doing a small print, it'll just give you what you need. So you don't have any of like that cold temperature fall off in the edges, which is a real common thing. It's flat, and then you can heat what you need. The other interesting thing is the print head itself. They've actually added load sensors to the print head.
Right.
So there's no more Z adjustment. You don't have to do a live Z adjustment. You don't adjust Z. It's all done numerically off of the load sensor. So the first layer is automatically calibrated by load sensors.
Wow.
And I thought of you when they also talked about this one. You've got your thermistor in the hot end to give you your temperature. They added a second one up further to help detect heat creep. So it can adjust by measuring heat across the entire hot, cold, and hot, kind of cool, and the cold end of the entire print head individually. So that's kind of cool. Yeah, I mean, it's interesting. This is like the first printer I've seen in a very, very long time that actually is introducing new technology.
Yeah, it's true. It's true.
So yeah, I'm super excited about it.
Yeah, the anti-clog detection stuff and the build plate having heated zones and being segmented sections, really cool. And also, it's just made with like the best parts. Yeah.
And the other thing that was interesting is, if you have a fan failure, you got the thermistor failure or whatever on the hot end, instead of having to chase the wires all the way through the umbilical, they actually have a quick disconnect plate on the back of the head now, so you can just plug it right in, and they got a breakout board on each head.
Wow. How much, Chris?
About $1 million.
Just shy of $1 million.
For a single head, it's about $2,000.
What? Well, is that what you pre-ordered, or did you pre-order a tool change one?
I ordered the 2-head, and they're $2,500.
Gotcha.
To get the full 5-head package, they're $3,500.
And then you can have them build it for you for an extra $500.
Yeah.
So if you want the 5-headed Hydra Ultimate Deluxe machine that they build for you, that's $4,000.
Which is honestly about the same price as a much smaller Ultimaker. I mean.
Yeah, it's true.
Yeah. Actually, for everything you were describing, $2,500 didn't sound all that bad.
No, I think it's pretty interesting. The other thing they added integral lights to the entire thing, so you can see the build plate. It's just a lot of really nice changes. They got sensors all the way through the filament path to detect jamming, filament out, skipping. They can basically measure all of that using big data. That they've been doing all these testing. They've been working on this for 2 years. So all those different variables, they've actually have numeric backup for it. They've actually built that into the system. So I don't know. I'm really kind of excited to see it.
When are you going to get it?
They say it's going to ship between Q2 and Q3 next year. So
cool.
So I gotta wait.
Well, you got to tell me all about it when you get it.
Oh yeah, no, I will. It's I'm excited about it.
I love just the silhouette of it too. I was watching a video of a couple like 3D printer YouTuber people at the event with just talking about how they like everything is so intentional with the way that it's sort of the opening of it is really accessible, so that if you print something that is the full build volume, you can actually get it out of the printer without having to like really finagle it through the frame.
Oh yeah, I took a saw to cut off one of those Core XYs to get the print out, because the way they built it, you couldn't get the print out of the box. That's pretty funny. But it's like I say, it's like the first printer in a long time that I'm actually excited about seeing steps forward in the technology in a significant way. So
what is the build volume? How big can it go?
14 inches cubed. It's big.
That's big. Yeah.
what would you print that big that it wouldn't take 3 weeks to make?
It's still going to take a while to print, but
Yeah,
you
but it's
can-
Core XY, so you can run it faster.
yeah, you can definitely run it a lot quicker. The one thing that they use is their use case for it is a lot of people who make cosplay or prop makers, they can print an entire helmet without having any sections in it.
Yeah.
I mean that type of a size. For me, if I'm prototyping stuff, sometimes the enclosure is big enough that I have to piece it together. It'd be nice to be able to print it all in one shot. Mostly, I'm looking forward to not as much the build volume, but the multiple types of filaments. Either doing multiple colored print or water soluble filament, I'm really intrigued with.
Yeah.
What would you do with the water soluble?
You use that for your support. So instead of having to, like make all these weird supports that get to break free, you can actually print this other material as your support structure. Then once the print's done, you take it all out and just set it in a bucket of water. That filament will dissolve in the water and release everything. So if you have a really, really complicated print, you can fill with the soluble support structure and just have it disappear. You don't need to worry about trying to cut it out or get in there to do it.
That could come in handy.
Yeah.
Okay, so I've got two other questions. One, sure. I'm going to forget. So that's about doing mold making. But going back to the different print heads. So you said it's got a tool changer. Does it just change filament, or it'll actually take off the print head and put a new one on for you?
Yeah.
So you can have up to 5 different heads. Wow. So it's a mechanical system that'll go up, lock, and then change out the head. And it has a auto. I don't know if you're familiar with CNC machining, where you got to basically zero out your tool. Mm-hmm. This will actually do all the automatic calibrations to set the tool heads up. So that's all automated as well. And the other thing that Prusa said, and it was kind of like an offhand remark, but I'm really curious to see what he meant by it, was with the tool changer, they are looking at other tools besides filament extrusion. And that was really intriguing to me to figure out what exactly they're talking about there. So it looks like it's a platform they're really planning on building on for quite a while. So
yeah. Well, shoot, if that's the case, I might have to actually look into getting one of these. If it can do a lot of different things.
Yeah.
It can't probably deal with the side loading that you would expect of a CNC.
I'm thinking more laser engraving.
Laser.
What my hunch is.
Which would be pretty
What other tools could there be?
Well, I know that they have there's that one printer that it's what's called the Snap Maker, and it's a 3D printer, laser engraver, and CNC cutter all in one.
Yeah, I think.
I'm sure it does all of those moderately well, but
again, I think Mark's right. I would be leery of the side loading. I mean, just having run mills. I mean, there's a lot of force behind them. Especially when you're trying to hog out, a lot of material. I'm thinking more laser engraving, maybe some light machining, but I'm leaning more toward the laser side of things.
Yeah.
Interesting. Okay, so here's my next question for you. My wife got me a propane forge for my birthday.
Oh.
So I wanted to melt some, certainly nothing ferrous, but some brass, bronze, aluminum.
Yeah.
What would I need? So are either of you familiar with the way to make that happen, from a 3D print to a metal casting in hand?
I can tell you what I've done. I've done the 3D printing individually, and I've done metal casting. I haven't done the two together. But I have done aluminum pours with oil sands and things like that. And I have seen it done where basically you are burning out the shape. So when you're pouring in the aluminum, you're actually melting out the PLA or whatever, you've done the mold around. So it's the same theory where when I was doing my oil sand casting, I basically carved my piece out of styrofoam. and then when you pour it in, it'll vent out. It'll melt and vent out. One of the vents you put in. PLA, I'm assuming, would run the same way. And I have seen it on, I've seen it on YouTube. I haven't tried it, but that's the way people do it.
So when you were talking about the water soluble stuff, what I was imagining was I print something out of that entirely, cast it in plaster of Paris, dissolve out the water soluble stuff, let it dry, probably bake out all the moisture, and then pour in.
That could work. I don't know how much does water soluble filament dissolve? Does it actually dissolve, or does it just soften?
It does. It takes 24 hours, something like that.
Gotcha.
For a while, but it does completely come out.
Okay.
My only thought with the plaster of Paris, I mean, you're still going to have it contained in something, some sort of, a sand enclosure, something like that, just to hold the shape. Just the heat from, especially aluminum and things, it's going to distort. So you would still need to have it somehow contained. But
interesting. Okay.
But that'll be fun.
In my copious amounts of free time.
Yeah.
You don't have free time. Nobody has free time.
I've read about it before. I haven't seen it.
Yeah. One of these
My
days.
friends talk about it with great fondness,
Yeah.
Yeah. So, all right, gentlemen. Well, thank you so much for your time. That was fun. We learn something new every time we do one of these. So
yeah, I'm anxious to try out the beta version of that Arduino IDE. So
yeah, me too. I'm not even familiar with the tools that I have been apparently missing. So who knows? Maybe my life will get a whole lot easier in a way that I didn't even know was possible. Now that I know that exists, because everybody was talking about debugging, and I was like, "Oh, is there a better way of doing this that I don't know about?" And
I haven't found it yet, but maybe this is it. We'll see. So.
Yeah, there's. It depends on what level you need to what degree you want to impact your life with this stuff. Unless you are an electrical engineer, you don't need to know most of this. So, anyways. All right. Well, thank you so much, Grant. Thank you so much, Chris. I'm Mark, and this has been Office Hours for Mark Rober's monthly class. We might do this again. We might not. But it's been fun. So thanks, everybody who's joined us all of these past few weeks. We'll see you around the internet. Bye, folks.
Bye, guys. Thank you.
Bye-bye. Talk to you soon.